Alright, you guys just copied down the helpful hints of doing simplifying trig identities. And I want to show you guys where that kind of looks like in the same warm-up problem that we just did. Okay? Here was the confusing part. You didn't know where to stop. But what happens if I gave you the answer? Would that be helpful? Yeah, so when we actually do identities, you're actually going to know the answer. And basically what you do is you're going to work on one side, and you need to get it to be the other side. So you'll have a starting point, and you'll have this ending. Okay? Think of it as kind of like proofs back in geometry. This is a given, and this is what you need to prove. Okay? So just read off the helpful hints to me. Crystal, read number 1. If I put this green one on this other side, class, which is the more complicated side, the fraction or the non-fraction? So the left side would be the side that I would work on. Number 2. Vincent.
Change everything into sines and cosines.
Now, we only kind of did that maybe at the end. So in this warm-up, you're still kind of doing the same thing. So I'm trying to show you that it's not really that much different. So there we change it to sine and cosine using the reciprocal identities or the other identities. Omar, number 3. We didn't have to do any factoring, but we have practiced that before. Number 4, Alexa. If you are adding or subtracting fractions, something like this, you have two expressions that you're subtracting. We call this rational expressions. In this case, I don't have two separate ones by addition or subtraction, so you don't have to get a common denominator. But if you did, we would need to do that in the problem. And Thomas, the last one? In this problem, we didn't have to do the conjugate, but the big idea I'm trying to show you is that you didn't know what the answer was going to be. When they verify identities, they're actually going to tell you what the answer should look like. So at least it has like a goal of where you're going.